Hey guys, this is CPM 3, Module 1, Lesson 4. It is over section 9.6, Linear Inequalities and Problem Solving. This one is honestly a very long lesson. It is 9 pages total. But it's really and truly a lot of the exact same thing. I probably have too many examples on here. So hopefully this will go rather quickly. It says first, the number line is integers to the left of 0 are called negative numbers. Integers to the right are called positive. The integer 0 is neither negative nor positive. So if you notice, we're kind of used to this positive number line. What you have to remember is that whenever you go to the negative side, it's almost like those numbers need to go backwards to the way we're used to, since we're so used to positive numbers. So it's got -5, -4, -3, -2, -1. What you want to make sure you don't do is when you come to a number line, you don't want to go like -2, -3, -4, -5. You've got to make sure that those negative numbers are kind of going backwards to the way that we're used to seeing things. So we have expression versus equation versus inequality. An expression has no equal sign. Okay, so for example, that would be something like 3x plus 4. So an equation has an equal sign. So for example, 3x plus 4 equals 10. So an inequality doesn't have an equal sign, but it has these 4 other symbols that we're probably pretty familiar looking at. And so it looks almost like an equation. It just has one of these symbols. So I'm going to do 3x plus 4 is less than 10. But this symbol here could be any of these 4 symbols here. Okay. And so we need to know what these mean. If you look at these two right here, it's almost, use them as an arrow. They're pointing this way. They're pointing to all of these negative numbers. And so this is your less than. And this one is your less than or equal to symbols. And so then these symbols here, used as like an arrow, they're pointing to the left, or sorry, to the right, like these symbols here, all to the positive numbers. So this is your greater than and greater than or equal to symbols. Okay, then we have some brackets. Your brackets go with the ones with the line. So they go with your greater than and your less than or equal to's. Then you have parentheses. This goes with your less than and greater than symbols. You have infinity. Infinity always gets parentheses. And then you have your negative infinity. And negative infinity always gets parentheses as well. And that's what this little helpful hint right here is telling us. Since we approach negative infinity and positive infinity, but never arrive at a number, we will always place parentheses around them. So that's just something you kind of have to honestly memorize. So objective A, define linear inequality in one variable. These are basically an example on this page here. So notice I'm going to skip all the way down on this page here. We have x is greater than or equal to -1. So when they graph this, you start at the number that they give you and use this symbol as an arrow. It's pointing to the right, so my thing's going to the right. So you have bracket at that -1, and you have a bracket because that line's under this. It's the or equal to. And then use this as an arrow, and so that's why it's going to everything more than. Okay, same thing over here. Now you have x is less than 1. So because it is less than, it's going to all these lower numbers and use this symbol as an arrow. It's pointing to the left. So my graph is going to the left. And then because this one has no line under here, this one gets a parenthesis. So the first part of this is just simply graphing these when we already have a solution. So graph the inequality. X is less than 2. So use the symbol as an arrow. It's pointing to the less than side. It's pointing to the left. So it means my graph is going to go to the left. And then because it has no bar under here, it means that this is going to have a parenthesis. So you know what, actually, let me just make this thicker so I don't have to keep doing all the lines. So we're going to the left and we've got parentheses. That's a lot easier. Okay, so now we need to graph this inequality here. So it's again pointing to the less than side. It's pointing to the negative. It's pointing to the left. So I'm going to start my graph at -1, and it's going to go to the left. And because this one has a line under it, now this one's going to have a bracket. Okay, now on this one, now it's pointing this way. So I'm going to start at -4, and it's going to go here. And notice that my line is going over that whole number line. If you guys want to just go like right here, that's perfectly fine. This arrow means it's going to keep going and keep going. It's never going to stop. So if you go the rest of the number line, or you just stop it somewhere in the middle, as long as you have that arrow pointing, it's correct. And because this one has no line under here, that means it's going to be a parenthesis. This one here, now notice on this one, we don't have this numbered. So let me number. Oh, darn. Okay. So when this is at 3, I'm going to go with 3 right here in the middle. And then you just need a number kind of 2 to each side. You don't have to number this whole number line. Just kind of go 2 to the left and 2 to the right. So that means bigger than it is 4 and 5. Lower than it is 2 and 1. And then that will be fine, just like that. So use this as an arrow. It's going in this direction. So start at 3. Use it as an arrow going this way. And then because it's got this line under it, that means it's going to be a bracket. Okay, same thing on example 5. We're going to graph this inequality here. So I'm going to start with that -2. And this is where you got to make sure you're using that number line correctly. When you go 2 to the left and 2 to the right, we're very tempted to go 3, -4, -5 going this way. But because we're on the negative side, it goes opposite. So more than it is -1 and 0. and then my -3 and -4 go behind it. Okay, so make sure you're numbering that correctly. That's why we kind of went over that number line. That's a very easy mistake that's going to happen. So when I graph this, start at that -2 and use this as an arrow. It's pointing this way, so that's the way my graph's going. And then since it's got nothing under here, no bar, means that this is going to be a parenthesis. Okay. All right. Since there are infinitely many such numbers, we cannot list all the solutions to the inequality, so a convenient notation is called interval notation. So interval notation looks exactly the way this graph is. Notice on this graph, you're always going from left to right, just as you read. It has nothing at 2, it has nothing at 3, it has nothing at 4, but it starts here at 5. Your graph has a parenthesis, so my interval notation also has a parenthesis. Then my arrow is going to the positive infinity side, and it's never stopping. So even though you only see 7 and you could see an 8 right here, it means it's touching 9, it's touching 10, 11, 12. It's going to keep going forever in that direction. So it's going to infinity, and infinity always has a parenthesis with it. That's what this helpful hint here is the same one that was on the very first page. Okay, same thing when you look at this graph here. You're always going from left to right. So my graph is starting from that negative infinity side. That arrow is going to keep going this way, so it's touching -10, -11, -12, all the way. It's going to keep going in that direction forever. So you're starting at negative infinity, and then how far is it going to the right? So it's going to -9, -8, -7, but it's not touching -6. So it's stopping here at -7. -7 has a bracket, and so does my interval notation here. Anytime my graph has a negative infinity, you're always going to start with negative infinity because that's the smallest number it can ever be. And anytime it's going to the infinity side, that will always be the last thing. So this is showing you examples of the exact same thing. Negative infinity to 1 looks like this. -1 to positive infinity looks like this. So you guys can use this examples here to kind of help you guys. But let's just go straight to the next page and let's just do some examples. So, given the graph, write the solution interval notation. So, we're always going from left to right. What is the smallest number this is touching? Well, it's pointing to the negative infinity. So we're going to start with negative infinity. Infinity and negative infinity always get parentheses, comma. What number is it going to? It's going right here to 0 because it's not touching 1. And because this 0 has a bracket, so does my 0 right here. So you're making it look exactly the way the graph does. Same thing here. You're going from left to right. It's starting right here at 3, and this 3 has a parenthesis. So parentheses 3, comma, and it's pointing to that infinity. So we're going to infinity, and infinity always is a parenthesis. Okay, so now starting at example 8, we need to graph this and then write this in interval notation. So we got a two-parter. So x is less than or equal to -3. So use this as an arrow. It's pointing this way. So at -3, we're pointing that same direction. And then because it's got this bar under it, that means it's a bracket. So to write this in interval notation, it's pointing at that negative infinity. So parentheses, negative infinity. Infinity always gets a parenthesis. And then it's not ever touching -2, but it's touching -3. So -3, and it's got a bracket just like the graph. Now let's graph this one. This one has no numbers. So we're going to start with -2 right here. So I got -1 and 0 is more than -3, -4. Okay, think opposite with negatives. It's pointing to the right. So at -2, my graph needs to go to the right. It's got nothing under here. So that means parenthesis. So my interval notation looks the same way. Starting at -2, and it's pointing to the positive infinity side. So infinity with a parenthesis. Okay, now 10 and 11 have a little bit different. They're giving me something. Like this one's giving me the graph. I'm writing the inequality and interval notation. This one's giving me interval notation, and I'm graphing and writing the inequality. So it's kind of the same as the other one. They're giving me one piece of information. I'm writing the other two. So I almost think writing the inequality is harder. So I'm going to start with this interval notation. Interval notation looks exactly the way this graph does. So it's starting at -1 with a bracket. And it's pointing to that infinity side. Infinity always gets parentheses. So I don't know why that just always is easier to me, because it looks exactly the way this graph does. So write the inequality. If you look at this other page here, your inequalities always have an X and then the number it starts at or that it ends at. We just have to really figure out what that sign is. So on this one, I know I have an X. I know because my symbol, my bracket or parentheses at 1, it's at 1. So now I have to figure out which of these 4 signs is it. Well, it's pointing this way. So I know it either has to be this one or this one. And because of this bracket, it's got to be this one here. So pointing the way that this graph is going, and then it's got the line under it because of this bracket here. Okay, so on this one, now it's giving me interval notation. And so now I'm going to graph it. So we're going to start with -3, and then number 2 to the left, 2 to the right. So that means -2, -1, -4, -5. It's pointing to the negative infinity side. And it's got a parenthesis here. So it's got a parenthesis here. So write this in interval notation. Starts off with negative, oh no, we already have interval notation. Interval notation's here. So we're writing the inequality, which is this right here. So I've got X, I've got my -3. So now we're just figuring out which of these symbols is it. Well, it's pointing this way. So I know it's either this one or this one. And because there's a parenthesis, it means there's no line under it, so it's got to be this one here. So pointing this way, the same the way my graph is, and no line under it since we've got a parenthesis. Objective D is using multiplication and division properties on it. Basically, when you are solving these inequalities, you solve it just like an equation. You do have one additional rule with these inequalities, and that's what this helpful hint right here is telling you. It says, don't forget that if both sides of an inequality are multiplied or divided by a negative number, then the direction of the inequality sign must be reversed. Okay. So basically, if you have something like -10x is greater than 100. When you divide by this negative number, it takes this symbol here and you've got to flip it and so now it's no longer greater than, now it's x is less than -10. Okay, you've got to flip it. So multiplied or divide by a negative number, you're flipping that symbol. Okay, so 12, for the following problems, solve and graph the solutions to the inequalities, then write the solution in interval notation. So we got x plus 5 is less than or equal to 3. So to get x by itself, the opposite of a plus 5 is a minus 5. We do this to both sides. So I get x is less than or equal to 3 minus 5 gives me a -2. Okay, so that's one of my answers. That is the solve part. So now let's graph. I've got -2, we got -1 and 0, -3, -4. Use this as an arrow. My arrow is pointing in this direction. So my graph is going in the same direction. And then because it's got the bar under it, that means it's a bracket, and so I've got a bracket. So now I'll write this in interval notation. It's pointing to the negative infinity side. So we've got parentheses, negative infinity, comma. It's going all the way to that -2, and that -2 has a bracket, so bracket as well. Okay, B is the same thing, but there is one thing that we've got to kind of fix on this one. When you get x by itself, it's x minus 4. The opposite of minus 4 is to add 4. So my 4's cancel here. -3 plus 4 is 1, so I've got 1 is less than x. When we have an equation, it does not matter if I have 1 equals x or x equals 1. These are both great. For inequalities, though, that's not so great. And so you've got to have that x first. And so that's what this little helpful hint down here is telling you. It says, notice that you have 2 is greater than 0. When you switch your 0 and your 2, you've got to switch that symbol. So now 0 is less than 2. Same thing with this one here. If 1 is less than x, when you switch this, when you switch your x and your 1, notice that in this symbol here, it's like this is pointing to the 1. Now I need my symbol to point to the 1 as well. So x is greater than 1. Why that's important is because we're using this as a way to tell me which way to shade. So when I have 1, 2, 3, 0, -1, if I use this first one, it tells me to shade this way, but that's not true. We need to shade it this way here. So it's really important for you to flip that so you know which way to shade. So we've got 1 going this way, and because you have no bar under that, means it's a parenthesis. And so in interval notation, it's starting at 1, comma, it's going to the positive infinity side, and infinity as parentheses. Okay, you got 5x is greater than 20, greater than or equal to 20. So you get x by itself, you divide by 5. So we got x is greater than or equal to 4. So then graph that. We've got 4, 5, 6, 3, and 2. So it's pointing this way. So we're going to shade that way. We're going to shade to the right. And it's got this bar under it. That bar means a bracket. So there's my graph. And then interval notation, it starts at 4 with a bracket. So bracket 4, comma, it's going to the infinity side. So comma, infinity, and infinity always has the parentheses. Okay, we're getting close to the end on D. D, we have this helpful hint down here. Don't forget that when you multiply and divide by a negative number, we've got to reverse that sign. So on D, you got negative 5x is greater than or equal to 20. To get x by itself, divide by negative 5. So you've got x, 20 divided by negative 5 is negative 4. And because we are dividing by a negative number, you have to take this symbol here and flip it. So here is my answer. Okay, you cannot forget to flip it when you divide by a negative number. So now when we graph this, we've got negative 4, negative 3, negative 2, negative 5, negative 6. This is now pointing to the left, so we're shading to the left, and it's got the line under it, so that means a bracket. So in interval notation, it's pointing to the negative infinity, so parentheses, negative infinity, comma, it's going to negative 4, and negative 4 has a bracket. Now, don't let this confuse you with this. This is not the same thing. On E, you've got 5x is greater than or equal to negative 20. To get x by itself, you divide by 5. So we've got x, 20 divided by negative 5 is negative 4. On this one, though, because I am dividing by positive numbers, I am not flipping my symbol. It does not matter that the beginning number, that 20, is negative. This is why I kept underlining this by. If we are not multiplying or dividing by a negative number, then this special rule doesn't apply to us. So we are keeping this symbol the way it is. Okay, see in this one, dividing by a positive number, and this one, dividing by a negative number. Okay, that's the difference between these two. So we've got negative 4, negative 3, negative 2, negative 5, negative 6. Use this as an arrow. This is pointing to the right. So I'm starting at negative 4, going to the right. And it's got a line under it, so that means a bracket. So then in interval notation, it's starting at negative 4, and that's got a bracket, so bracket negative 4, comma, it's going to the infinity side, so infinity with a parentheses. F and G are the exact same things, but now we've got multi-step problems. So in F, negative 4 plus 7 is greater than negative 9. So, to get that plus 7, we're going to subtract. So I've got negative 4x is greater than negative 16. To get x by itself, we're going to divide by negative 4. So I've got x, negative 16 over negative 4 is a positive 4. Do I need to switch the sign. Is this like D or is this like E? This is going to be like D. We need to switch this. Because we are dividing by a negative number, we need to flip this symbol here. So we're going to, instead of it being greater than, now it is less than. So my final answer is X is less than 4. So I've got 2, 3, 4, 5, 6. This is going to the left, just like my symbol is. So that means when I start at 4, I am going to the left. No bar under here, no line. So that means parentheses. So in interval notation, it's pointing to the negative infinity sign. So negative infinity, comma, it's going to the 4, and the 4 has a parentheses. And then on G, it's got parentheses, so we need to start by distributing. So I've got 8 is less than 2 times x is 2x. 2 times 4 is 8. So goal here is to get x by itself. So I'm going to subtract 8 from both sides. Well, notice here 8 cancels on one side. Sort of cancels on the other side too, right? 8 minus 8 cancels here. So 8 minus 8 sort of cancels there. But to keep a number there, we're going to put 0. Now, don't stop there. 0 is a number. We can still get a solution here. So how do you get x by itself? Divide by 2. My 2's cancel. 0 divided by anything is 0. So I get 0 is less than x. Don't remember, or please remember, just like one of these pages over here, we had to flip this because we need x first. Okay, same thing here. I need x first, so this is going to turn into x 0. Notice that this is pointing to the 0, the symbol, so that means I need my symbol pointing to my 0 as well. So this is my solution. And why that matters is you want to make sure you shade the right way, right? So we've got 0, 1, 2, -1, -2. If you keep it this way here, it shows I am shading the negative side, but I'm not shading the negative side. I am wanting to shade to the positive side the way my answer is looking. So we're shading this way, and that's got no bar under it, so parentheses. So in interval notation, we've got parentheses 0, comma, it's going to the infinity side, so infinity and then parentheses there. Okay, and then last page we've got 2 more problems. We've got one-step problems with fractions. So you can do this in 2 steps if you would like. You could rewrite this as -2y all over 3. So you'd multiply by 3. -2y is equal to 24. Divide by -2 and we get y is going to be -12. I don't recommend doing it that way. The easiest way here, and that's why I went through that so fast. I don't recommend it, but you could. Do this all in one step. We're going to multiply this by the reciprocal. The reciprocal just means you flip that fraction. So instead of this, instead of this being -2 over 3, I'm now going to multiply this by -3 over 2. My 3's cancel, my 2's cancel, even my negatives cancel. Negative times negative is positive, so I am just left with y. And then what I do to one side, I've got to do to the other. So if I'm multiplying this side by negative 3 over 2, I also need to multiply this side by negative 3 over 2. So when you multiply straight across. So if you would like to, you can make this 8 all over 1. So I've got 8 times negative 3, which is negative 24. 1 times 2 is 2. And then negative 24 divided by 2 is negative 12. So if you kind of rewind the video, you'll see when you did that in 2 parts, you did exactly that. You times by 3 and divided by 2. So same thing, but this is just one step, takes up less room. So now we've just got to figure out, what am I going to do with this symbol? Does it stay or do I need to flip it? Well, because I am multiplying by a negative number, that means we do need to flip this symbol. So this becomes y is greater than or equal to negative 12. So we're going to start here at negative 12. This is negative 11, negative 10, negative 13, negative 14. When I shade, use this as an arrow, it's pointing to the right. So at negative 12, this is going to the right. And it's got that bar under it, that line. So that means this is a bracket. So when I write this in interval notation, I've got bracket, negative 12, comma, it's going to the infinity side. So infinity with a parentheses. Okay, so same thing on I. I've got negative 3 over 4. So we're going to multiply this by the reciprocal. So I'm going to multiply this by negative 4 over 3. My 4's cancel, my 3's cancel, and negative times negative is positive, so those even cancel. So I am left with y. What I do to one side of the equation, I have to do to the other side. So I'm going to also multiply this side here by a negative 4 over 3. Okay. If you need to, you can make this 9, a 9 over 1 to make it into a fraction, but multiply straight across. 9 times negative 4 is negative 36. Don't pay attention to those. 1 times 3 is 3. And weirdly enough, negative 36 divided by 3 is negative 12. So we get negative 12 for this answer as well. So now just figure out, do we need to change this symbol? Well, I am dividing by, or I'm multiplying by a negative 4 over 3. So yes, that means you do need to flip this symbol. So instead of it being greater than, now it is less than. So my graph's going to look almost the same. We've got negative 12, negative 11, negative 10, negative 13, negative 14. It's going to look almost the same, except for now my graph is pointing to the left. Use that as a symbol. It's pointing this way. So at negative 12, my graph's going to the negative infinity side, and it's got no bar under it, so it means this one gets a parentheses. So then last time, in interval notation, it's pointing to the negative infinity. So negative infinity, comma, it's going to negative 12, and negative 12 has a parentheses. So this one was a kind of a long one, but please feel free to rewind and pause this video as you need to. And if you have any questions, let